All right. So again, just starting from the top real quick, objects, object literals, JavaScript object and object literals are pretty much the same thing. So uh, I just want to, I just kind of want to stick with object literals for the terminology right now, just so I'm not saying object a lot, because if you ever work with any other language, object might have a different meaning. So I'm going to call them object literals, but you'll also see them on NVM called objects, or that's the thing that we're going to end up calling it a lot because we're not going to call it object literal in our code. Anyways, this is all just like trying to keep terminology straight between languages for me. So um, again, what is an object literal? An object literal is a data type. It holds a collection of properties where each property is basically it's a mapping between a name and a value. So you can create as many of these mappings or associations that you want between a key and a value. But your key inside of this thing called an object literal, your key is always mapped to that value for that given object. So what this might look like, so these objects you can represent almost anything you want. So anything that has attributes in the real world, or it might not even exist as an object in the real world, but you can represent just even abstract concept, like a thing that just doesn't exist that you can physically touch, right? Like a water bottle. It has attributes, right? It has like volume, how much liquid can it hold in it. I could represent this in an object. Pretty simple. I can give it key value pairs where I say one of my keys is volume, and then my value to that might be like some kind of decimal number, or however I want to represent the volume of liquid inside of this. So you can use this structure is pretty useful. You can use it for a lot of different things. uh, it's really all about how you want to visualize your data. And sometimes you're going to be structuring your representation of what you want for the data, or sometimes it's already going to be given to you in some kind of form, and all you have to do is realize what you're working with. So if it's an object, just from at this level, I can tell this is an object because literally by to the right of the equal sign, I have curly braces. Let me do this annotation thing. Where is it? So I have these curly braces and opening, closing curly braces. And my key here, like the key is obviously it's to the left of the colon. And that just seeing these things right here, I can immediately tell like this is this kind of object type. It is an object literal. And once I know that, I know how I can interact with it. And that's like your first important step as an intro beginner, for any developer. That's your first step, is knowing your data type. Like, what are you actually working with, so you can know how to interact with it. Um, so inside this variable that I'm creating, there's an object. It has 1, 2, 3, 4 keys, and these have to be unique. So I have to I have to kind of lie to you for a second, because there's like more custom structures of data, or there's more customizations you can do to data types. But for the time being, let's just go with the idea that you can only ever have one unique key inside of this data type. There are ways to customize this later when you get more intermediate, where you can share keys, but that's beyond the scope of anything we're going to learn. So for now, your key is unique. First name, there can only be one first name when JavaScript looks at this, with one value attached to that. And that's kind of how this data type works. So first name is bound to whatever I put in here. Right now I put nothing. I just put all empty strings for all these because right now these values don't actually matter for the moment. We're gonna dive into all the different types that we can work with in here. And going off of that, they don't have to be strings and numbers, right? Like they can be any data type. I can nest another one of these objects with key value pairs as a value for any one of these keys. So first name, I could have just put first name and opened another set of curly braces inside here and had like a nested object inside of an object. Please tell me that at some point all the braces and brackets and parentheses will make sense. Yeah, each one kind of has like It's part of the syntax. It's just learning the syntax, right? Like it comes with practice. Because yeah, I know. I helped a few students work with some code, work with some of their problems, and some folks just like throw in parentheses, but if you call parentheses after something, it might think it's a function call, and it's going to try to treat it that way. And if you have opening and closing square brackets, right, the ones that are more square and less curly, it's going to treat it like it's like an iterable of some kind, like a array or a string where something that you can index off of. It's going to treat it that way. But yeah, we can go over some examples for that, because it does get tricky, all these braces, brackets, and some languages want you to not put, well, some like JSON, valid JSON, you can't end with a comma down here. There's like all these like subtleties that you have to know about, but you learn them on the fly, so it's fine. So objects, keys, and values. An object literal keys and values do not, yeah, I already said this, do not have to just be a string data type. They can be other types as well. So kind of through like a quick example of what else you can do. So you'll notice that I gave four different keys in here. So if I talk to the organization variable, I can ask it for, I can say, hey, organization variable, give me your name. I'm trying to access a value by its name. So you can think of it as this value has been given a name attribute within this variable. This is going to make more sense, I think, in the next coming slides. But I can basically ask it for that attribute by its name. I say, give me the name, and its job is to return the value. If I say, organization, give me your, I'm trying to access your name attribute, give me the value attached to that, that's what it would get. It would give me back this value. Same thing with type. Topics is not a string, but it is an array of strings, at least in this example. So this just shows you that you can have an object literal, your key can still just be just like a regular key value pair mapping, but now your value, your data type has changed. So now you have another, you're basically creating this nested structure of your own now. So you're saying topics, I don't want to just hold one string of topics. I might want to hold a lot of different topics inside of my object literal, because it's trying to represent an organization like Platoon. So literally, I'm just representing inside this one object, one organization. So inside here we have, I'm gonna create this data type, and then we're gonna interact with it, just so you can understand the interaction of this data. I think someone unmuted their mic. Got you. And then also down here in cohorts, you'll see that I didn't finish it. This is not valid, but I put the opening and closing braces with one key, and we can start building some much more complex structures of data this way. So I have organization itself as an object literal. Cohorts down here, the value of it is an object literal, where it has one key at the moment, which is a number. So the keys don't just have to be like string labels. Well, that's what it turns them into. But you'll see that like I can have numbers as the key, and then the value can again be another array. So if this isn't setting yet, it's hopefully going to soon. So interactions with an object literal. Again, very simple case. We have two keys. Both of them are string values. And so if you can access these values by their key. So if this is my example, if I wanted to access the value that was contained within this object, I would refer to the variable by its name, because that's what's holding this object. This entire object is bound to organization. So if I say organization, I can use dot syntax and say dot name. This would console.log my value, whatever is bound to that name inside that object. this one single object. And then if I console.log, I can also use the bracket notation as well. So I can say, I can put square brackets instead of using the dot. There is a use case for using one or the other. I'll have to show you it because there is a case where you pretty much have to use square brackets. And it really depends on how you've named your key. So organization, I can use square brackets, and I can access basically the same exact value the same exact way. These are just two different ways to write the same thing, but dot syntax has a gotcha to it. It has something. It's starting to get dark. I might have to turn on my light in a minute because it's getting pretty dark in here. My face is just gonna go completely dark in a minute. So got to close the console.log. Oh, right, yeah. So yeah, so I'm missing there's a syntax error here. I'm missing the closing parenthesis that's meant to be right here. Good catch, good eye. So just keep this in mind. This is just this type of object. Just like an array uses square brackets and you comma separated values in between them. This is the way you define this type of object if you want to use it. And so once we have this type of object, we can actually start using either methods or other things that are built into the language to do more interactions with it. So because objects aren't index based like an array is, where if I wanted the first item out of an array, if I wanted to find an item in an array, I have to like loop over every single item to find that item, right? Because I might not know exactly where it's at. I don't know what position in that array it's at, but an object works differently. It says I have unique keys for references. If you know the key name, if you know the like friendly name that you've given this thing, I can give you that value, and I don't have to iterate over the entire object to find it because they're unique keys. I can find it instantly. It's kind of like a dictionary. If I tell you what word, if I tell you what word in the dictionary I want you to look up, you don't have to start from the front of the book, right? You don't have to start from the A's. If I told you to find the word organization, you wouldn't start from A's and then flip page by page going through this like array of pages, right? You would probably open halfway through the book and like kind of see where you're at. This isn't what the code's really doing. It's like it's immediately knows where to go. It's like I start with the word organization, and it knows that that's a unique key. It can open directly to that spot immediately. It doesn't have to iterate over anything to get there. So knowing that, if I happen to know what my key is, there's a few ways that we can do this. I can say, if I give it the name of the key, like I have to put it in quotes because we'll have to experiment with this just so you can see the behavior of this object. But for now, let's just say, all of your keys are going to be strings. The way you're going to use this syntax right here, when I say if the key is in the object literal, like this is how you can make it behave. I can write a condition where I ask the object, do you have this key inside of your object? And then based on this object right here, this statement would be true because the object knows how to check for containment. And that's generally what they call it, is when you're checking for an item to exist inside of an object like this, like an attribute, you're checking for containment within that object, or you're asking that object to see if that thing exists. So it returns back a true or a false based on if this key is physically in this object. And then you can run code based on if that key is contained in there or not. And there's also a method, because we learned about methods, right? String methods and number methods and array methods. Objects also have methods. One of them is called has own property, and then you pass it the name of the key. And I've conveniently called this thing name to, Hopefully it's not making it too much confusing, but I could have passed any of the keys by their name as the argument because it's a method, right? And this will also return a true or a false. So these lines are almost, they do basically the same thing. It's two ways to do the same thing. So again, we have built-in methods for, we have built-in methods for an object, well, for a data type, right? So let me turn this off. So object has a few. I'm gonna open this link up, I think, because there's two different things happening, because we briefly touched on static methods and then instance methods, and these aren't written in the best form to know which is which right now, because they all look like they're static methods at the moment. So if we come down, here, we can see static methods. When you work with objects in JavaScript, a lot of times you're going to use static methods. I think in a lot of cases I've used. I think this probably threw me off the most when I first came to JavaScript, is having to call the object itself and its static method, and then pass it basically like an instance of an object. So like our instance would have been, let me go back. The instance that we created right here, like the actual value, this would have been our instance. So we basically have to pass this to our static method. So like object entry, here, let me show you. No, that's not a good one. I don't want to get too far with that one. What's a good one? Keys, maybe. So this is their instance, right? They're creating an object. It has 3 keys. It's a string, a number, and a Boolean. And they're saying console.log, they're trying to log out this method call. It's a static method, and you notice how they're passing their literal, their variable that holds this specific value inside of it. So the static method does work against an object of the same type. And they're expecting to get back an array of A, B, and C. That's because their keys are A, B, and C. So this is how you can like have JavaScript talk to any of your objects. And we can run it and we can see that we get back an array. We can also change this to values, and we can get back nothing but an array of each of the values. There are use cases for all of these, trust me. And then entries will give us back it looks weird, but it gives us back a 2-item array where the first item is always the key, the second item is always the value that goes to that key. This is a really weird way to look at it like this. Maybe I'll make a better example, because this is not easy to read. Anyways, this is just to highlight that objects also have methods, and we're gonna go through how to use these and what they look like, and then I'm also gonna come back and we're gonna create like this organization object, and I kind of want to show you how you can at face value right here, it doesn't look like it's that useful if I'm just hard coding in like these organization. Well, if I'm just creating one object and then asking it about that object, it's more useful if I have a lot of objects that I can talk to using the same logic, and maybe I can integrate some kind of function. So we can go over something that Deborah wants to see too. All right, so yeah, let's hop into I'm gonna hop into a REPL session, and then I'll quickly throw together. I can't copy paste from here because these are not. I'm gonna make something like this organization. We're gonna represent something. I mean, we can literally represent anything. Let me turn on my light, because it's getting dark. So yeah, let me just throw together real quick. Organization, we'll do the same kind of thing here, where I say code platoon, and the type is non. I'm just picking arbitrary values here, and then we'll say, well, not too arbitrary. I guess these are correct. What was the other one? I had like cohorts. I don't want, that one's pretty complex to do at the start, but let's just leave it. Let's just leave it as this for the moment. Let's just leave this for the moment and interact with it, and then we'll add more. We'll build it up, because my eventual goal here is to like say, let's see. My ultimate goal is to show you something more complex, right? So something that's like, I want to be working with data that represents a lot of organizations. I'm picking this, but I don't have a lot of organizations in mind to do this. But let's say your data structure is eventually going to be something that's more complex, right? Like it's going to be, maybe there's 100 of these things, right? Like maybe you have 100 organizations that you need to represent with attributes, and you're trying to display them on a website or something, right? So each one of these items is an org, right? Like each one of these, doesn't really matter what order. We're going to pretend like order of these organizations doesn't matter, but they just need to be part of this array. So now we're combining an array with all of these objects. This is my eventual goal. I want to get you to understanding how to like create this structure, and then like loop over this type of a structure, and just do something with it, because a lot of times you're going to be working with something more structured data, rather than just like these one-off objects, or like one string, one value, and just doing something with that. So first, by example, we want to know how to talk. Can you say curly brackets are objects and square brackets are arrays? No, I'll show you. It's so here's where things, here's why I can't say that. So organization, I want to I only have, it's only one organization right now, one object that we're interacting with. I want to say, tell me what the name of this organization is. So I'm accessing it, right, by with the dot syntax, because an object, I can use a dot, and then it's going to perform a lookup for me. It's going to say, all right, I'll go find the value attached to that. This is really your key that goes here, any one of those keys, right? So if I say that and I run it, code platoon, cool. It retrieved my value for me. And I didn't have to be very specific beyond attaching a name attribute to it. So I can do the same thing with type. So it's going to print out the name and then the type. Cool. So it does these basic things. So again, like I said, we can say, I can say, use the bracket notation to access a key, to still access by a key name. So now I get code platoon, right? The one tricky part with dot syntax is if I come in, I'm going to show you how to add another key, maybe somewhere later. I wanted to attach another piece of data to this organization, right? I could come in here and say like, I don't know, what's a good one? What's a good attribute that has 2 words to it for an organization? Let's see. I'm just gonna I can't think of anything off the top of my head.
So, location.
Yeah, well, I need like 2 words though to really demonstrate this thing.
Location, Washington.
No, no, no.
Oh, two worded. Okay.
Like where located. I don't know, something like that, right? And we could put a value of like Washington in there. So I'm making this my key. Um, yeah. Or can we do? Yeah, I guess that's good too. So we could say like city state, right? This is my key. There's a space in there. This creates a problem with the dot syntax, um, because now what happens is JavaScript's going to still try to read this like, um, left to right, top to bottom. And when it comes in here and I say access, use dot notation to access city, I can't put a space here because this space immediately is going to tell JavaScript that we're done writing what attribute we were looking for. Like when it hits the end of that city, that Y, and it sees the space, it's like, all right, I'm going to go try to find the attribute of city. Doesn't exist. We can't do this because, again, it just creates this problem where JavaScript is going to go look for city, but then it's also going to try to interpret this next line where it's been separated from our dot syntax key that we're trying to access. It's going to see state and go, I have no idea what that is. It's going to say, syntax error. Make sure I didn't miss something here. Yeah, city. So it's missing a parenthesis after the argument list. I guess maybe console.log is failing because I have a space in I have a space in between these two things. I guess if I put a comma. So yeah, it just blows up, right? The code is just blowing up because it doesn't like that now I'm referencing state. State is not a thing in here. It's not a variable. It's not a function. I'm trying to reference something that just was never set in the first place. So that's why I get a reference error. It says state was never defined, so can't run this. And I can't do anything clever like maybe JavaScript will auto magically smash these together for me, like that, maybe. So it tries, right? It didn't fail, but we got an undefined because it still didn't find that key. So if you want to use dot syntax, you have to make sure you don't use spaces, or whatever you're using doesn't have a space inside the key. The key can't have a space. So usually a lot of times you'll see it like this. And if I get that space out of there, then we can totally do like city state like that, and it will be Washington. So that's just kind of like, this is just dot syntax. If you prefer that, yeah, automagically. It's my favorite word, I think. The dot syntax, it just has a problem with that. But the bracket notation doesn't have a problem with it. I can leave this in here, and if I just use the bracket notation, I can still access it by this very specific string value now. And when I do it now, it doesn't fail. So bracket notation is more accepting, and dot notation wants a very specific way. So keep that in mind when you're choosing between using the dot syntax or the bracket notation, right? So, and if I wanted to define it beforehand, right, I could have just said, because of this space is the problem that I need to put here. I can't do this. It's not going to work. So because of that special character, I could set it like this. And you know what? I didn't try it this way, but I'm curious what's going to happen. It should still give us the same kind of behavior. Let me comment that one out. And so again, I don't think JavaScript is going to help us in any way with this key. I was making assumptions. All right, so this is good. I'm gonna leave it like this for the moment because I want you to see the next thing that we do, which is work with these methods. I'm gonna go through each one of these methods just because each one of them is kind of valuable to look at. You'll actually use a lot of these. probably, I think the most, you'll either use has on property or you'll use the keyword in, like this slide had right here. Like you'll either treat it this way or you'll treat it this way. It does the same thing. So for the time being, I think I'm going to go over these ones real quick. So keys, values, and entries. They each are very consistent, right? They each return an array of either keys or an array of values or an array of arrays that contain keys and values. But we're going to look at those real quick because when you start nesting data types, things get interesting. So let me console.log object.keys. And because this is a static method, I have to pass, well, let me do it the way that folks might misinterpret the method. So if they thought this was an instance method, they probably would have done this. So let's run that. It says type error, organization.keys is not a function. So we can't call .keys literally on the object, which means if you get this error, it's probably because you meant to do this organization. So I'm passing my object into the JavaScript's, I'm basically using JavaScript's built-in object static method, the attached static method to their built-in object, which is, this object is what is used to create your object or the instance that, this one instance that we're creating, but we're just using like this base, I'm trying not to say class. I don't want to get into object-oriented programming. I'm always trying to avoid that conversation at this early of a stage. But objects, we're basically using like their built-in version of an object, which has static methods attached to it. And for the moment, you just have to know that a static method, this is kind of the syntax of what you call it. You say the data type in which it's called, followed by dot, and then the method name. This is for when it's a static method. And then we pass it our version of that object. And then when we run this, you can see that it gives us back, the brackets, which kind of signifies, in this context, it signifies an array. Like we have received a return value with a bracket with comma separated values in it. And you can see they're all the keys are represented as strings. And if I do the same for values, I'm basically asking this object to give me its keys or give me its values only. I'm trying to single them out. And the best way it finds to do that is it goes through each of the keys and grabs each of the values. So now I can see that I lose the context for what the key was called, but maybe I don't need that for whatever you're doing. Maybe you just don't care about the keys. You just need the values from this thing. It exists because somebody had a use case for it. So entries, entries is the interesting one. So you'll see that we get this nested structure, right? We'll see a lot more brackets in here, square brackets, right? We have an opening and a closing that surrounds the entire thing. And then there's commas in here. So going back to arrays real quick, this entire line right here is index 0 of the outer array, right? So this whole line is index 0 or the first item in the array. This is index 1, which is the second, because arrays count from 0 again. So each one of these lines is an array data type. Like the value of index 0 is itself a data type of an array. So you can nest data types. And this is how you create more complex pieces of data that you want to, like, if I wanted a array of organizations and every organization had like their values in there. So I could represent this as an array of arrays, or I could do this an array of object literals. It's really up to you as a developer to choose that, and whatever you pick is going to basically determine how in the how your future code is going to interact with this data. So at the moment, I've decided to use entries, and entries gives me back an array of arrays. And if you're tracking up to this point, like this index, this line right here, index 0 is an array. There's this array is also indexable as well. So this might seem kind of crazy at first. So I don't know if I'm losing anybody right now, but let's break this let's break this down for a moment. So if I say we'll just call it entries as well. Entries, it's plural. It's going to be entry, like a lot of entries, right? So there's going to be 3. Now, if I say entries 0, I'm really saying this outer container of my array, this is the first item in there, right? 0 index would be this entire line. But let's test that. Let's make sure that's correct. This is my assumption. So it gives me a return value of an array. But that is also, because it's also an array that has come back, I can index an array. I can index the index of that because it's a nested array. So I can actually say, give me index 0 of index 0, because this first one is an array that comes back. I want to index that array that comes back. What does that give me? It gives me name. Let me put them both on here so you can see them side by side. So actually, let me do all 3 of them, just so they're all side by side. So you can see that this is a nested array. And then the first item of that array, index 0, is this one. Sorry, let me increase the size actually. Forget about that. So we have our outer array. The first item is index 0. So I'm basically console.logging these on separate lines. So this is the second console.log. So it's printing out our first index item. And then I'm indexing this array by 0, which means the first item in that array, right? So this is how you can like traverse the first items out of the array manually, or you can use a loop to do it. But this just lets you convert an object literal into an array of arrays, because maybe you have a use case for that. All right. So yeah, let me go back here. So, and I mean, I already went over these, but this is the way you can visualize if arrays of arrays are a little bit confusing. I think the easiest way, I know this is supposed to be object literals, but because object literals let you convert into arrays. Here, let me open up. Do I have it? I already have it. When I think about arrays of arrays, when you have a single dimension of an array, right? When we have just keys, let me console.log this out. I'm gonna make this make sense. Because you are gonna interact with arrays and multi-dimensional arrays quite a bit. So this is a single dimension, right? We would call this, I would call this like a 1D array. It has one dimension. It's, yeah, we would just call it a 1D array. And the way I always visualize this, if you've ever worked with spreadsheet software, one dimension, you can think about it either it's just the column going down or it's just the row. You can write your code to go down a column or across the column any way you like, but it's only one dimension. So either I have to go this way the whole time, or I can only go this way the whole time, but I can't go across. I can't grab all of the data. So if it's a multi-dimensional array, think of a spreadsheet. If it's a 2D array, you're basically going across this spreadsheet. Somebody got it. Okay, so that's just for me to lead up for entries right here. I just wanted to say that and prefix it, just so y'all understand that this thing that's entries here, when I print this thing out, I want this to be obvious that, oh, I guess I should fix my name here. When this prints out, this is a 2D array. This first one is the outer one dimension, but this inner array is adding the second dimension. So you can think about this like the outer one can be rows and the inner one can be columns. You can write your code to traverse this thing rows to columns or columns to rows, but all you have to know at the end of the day is that one of them is representing like your column positions or what your columns are, and the other one is literally, one is going across and the other one's coming down, right? And if you have those dimensions all the way through, it's a multi-dimensional array. This is basically it. You'll see that every inner value is 2 items, right? So this means that our array, or I mean our spreadsheet, if this was going to become a spreadsheet, it would physically be 2. It would be 2 columns right here. Let me write it out. So we have name, code platoon, type, nonprofit, city, state, and Washington. So I could make my keys my header row, right? I'm kind of sidetracking into arrays here, but it's fine. City and state, right? So these are like my column rows, and then these could be my values that are bound to those rows. So this would be code platoon, and this would be nonprofit, and this would be Washington, right? And I could have a lot of these, right? Like this could keep going. I could have more columns if I wanted, and this could keep going. So I'm basically representing what I could in a spreadsheet. So if the more keys I have, I would basically be going down my columns here. And this is actually how you end up reading when you get to like reading a spreadsheet, like a CSV file in Python or something. You can actually read in values from this, and it'll put it in Python in a similar structure, like a multi-dimensional array. And then you can loop over it once you know what data type you have. All right. So going back away from arrays for a moment, I just had to do that mostly because y'all, if you use this, you're gonna end up using it. You're gonna be swapping from an object to an array. Your return value is gonna come out as an array, so you got to make sure you keep treating it as its type. All right. Let me stop there for a moment. Is everybody tracking so far? Or are there any questions about this, like this type, this data type itself? All right. Tracking so far, so decent. Yeah, it's not too. Once you get your head around the mapping of the key value pairs, it's pretty consistent across the board. So my ultimate goal down here was to create something more complex and then like do a proper like interaction with it, right? So let me get rid of some of this stuff because yeah, let me get rid of. So for the moment, I'm going to let's keep it small again, and I want to make this thing right here. I want to make this set of organizations, and so this is going to be the type that this is already starting off to be. It's an array of object literals. Whoops. Right? It's an array of object literals because open brackets, close brackets with comma separated values. Values can be any data type. This is starting off, well, I'm choosing it to be object literals. But object literals can have key value pair mapping, so I can nest even more data, like even more data. We can make this thing super complex if we want. I'm going to try not to do that because I don't want to like blow minds with. When you start working with REST APIs, the structure of data that comes back, and some of them are pretty crazy. Like they're nested sets of data, lots of data. if you're going to be a data scientist, it's going to be your most favorite thing is the complex structures of these data. So I'm going to write these in myself, right? So I'm basically going to follow this same each item inside this array is going to represent an organization. So at the moment I'm copy pasting this, and we can change these for profit, and I don't have names off the top of my head. ABC company, right? I don't know. These names don't matter. DEF org, XYZ. Yeah. Anyways, so I don't know what else we can. I'm just gonna just keep this kind of simple for now, because the more actually, let's just stick with 3. Sure. I don't want to spend too much time just getting caught up in custom creations of data here. All right, so this all looks okay. I don't have any syntax errors, it doesn't look like. So it's an array where every single object literal has the same keys, right? I have a name in each one, I have a type in each one. How do I don't want to do this, right? Because my outer container is an array. I don't want to have to manually access this because it has no meaning. I don't know what that first item might be. It could have been sorted in a different order, or XYZ could have been first. I don't want to make this assumption. So I guess something that we can do is we can loop over, which loop do we want to use? We'll go back to this one. It's tends to be a one people either like or don't like. Organizations length I++, right? So I starts off at 0. We're going to iterate. We're going to use this index 0 every time it loops. Every time it comes back to iterate again, it's going to increment I one at a time each time it does the loop, the thing in the loop, right? So interacting here, I'm going to draw this. I'm going to draw this out a little bit longer than I need to, probably. These lines. Can you put this in example on Slack? Yes. Yep, I sure can. Let me get more of it done. I think I didn't finish our last challenge, but I kind of left it open so other people could finish it. From I think it was the last session. Just lost my train of thought. Okay, yeah. So I'm grabbing. Does it make sense? Does it make sense if I do that right here? Does it make sense what that is going to become every single time? Right. So the first iteration is gonna be organization 0, right? And then it's gonna be 1, and then it's gonna be 2. So every time it comes back around, it's gonna start from 0. So it's gonna grab 0, right? This is 0, this is 1, this is 2, because this is an array of index positions. So that means org itself is going to hold one of these at any given time, just one of them. That means I can talk to that thing. If I say org.name like that, it we'll be iterating over the organization's array of object literals. So we are iterating over organization's array of object literals. That's what we're doing, and then we're basically storing one of those objects in our variable at the each time it comes back around for this for block, this for loop, and then we're going to console.log the name out. So because this line is kind of, this line makes it kind of powerful, right? Like this lets me talk to my object literal in a more friendly way than saying, like, if it was an array of arrays here, I would have to like know what position was first. Like I would have to know that name is first. But when you're reading code, most of the time you can't see this variable. Like you can't, it's coming from somewhere else. So then you're left with looking at this code. Like this has, what is this? Like, I don't know what 0 is. I'm gonna have to go look it up. I'm gonna have to go like dig into the data and be like, all right, when this thing comes in, what is that piece of data gonna be? So it's almost, when you're able to pick your structure that you want, it makes it a lot cleaner for you to interact with something this way. If I say org.name, that has more meaning to me when I look at it. When I look at this, all right, it's console.login, a name of this org as we iterate. So we can do, let's see, what kind of, I know Deborah wanted to see like a function, a use of a function inside of this array, but let's see, what is something we can do with this data. Can't think of anything off the top of my head. I'm gonna make it bad data, I guess, right? I'm gonna put all these extra spaces in here. Maybe this is uncleaned data, as they would call it in data science, right? It hasn't been cleaned yet. Like all my objects came in and there was like a bunch of like trailing spaces or something. So maybe I need to loop and I need to like kind of parse, before I display these values, I kind of want to like process, like do like one stage of processing to these values. So let me do like I'm contradicting what I told you right now. So trim white space, right? I'm creating a function the old style way for the moment. Trim white space. It's going to take one argument, which is going to be the thing that I want to trim. And I'm totally creating, hopefully you follow this. I know Deborah wanted to see this, or anybody else. Hopefully you're following what my plan is here. I want to clean up this value. That's my goal. And this is probably a real life scenario where you might have to like iterate and then clean up particular values in some structure that you were given from an API or you scraped from the web or something. Like there might be a lot of white space and you want to clean it up so it looks proper, like you strip off all the excess characters or something. So it needs to take, we need a parameter, which is going to be a string value. So maybe I'll just call this like, we'll just call it string for the moment, because the thing I'm going to pass in is going to be a string, but it's going to store that in a variable called string. And then, does anybody remember off the top of their head? There is actually a string method, so a function that's already built into the string data type that can already trim, but we could use that, or we could do it ourselves. I don't know which one would you all want to see. No, not pop or slice. There's actually one called, I think it's called trim. Actually, let me look it up, because now if you can't remember like me, so there is a slice, but oh, there it is. So there's a trim. It removes the white space from both the ending, both sides, the start and the end. So I could use this, or I could write it myself. Yeah. So a string type has a trim. Maybe I'll do both. I don't know. Let's see. So trim gives us back a new, let's look at it real quick again. So if there's white space and there's white space, you would get all of the white space in there. But if you called, it's an instance method. If you called trim on it, it would give you back the new result of that. So it needs to return back. So we want to return back the result of the string method, which returns back the result. So we're returning a return value here. If you want, I can go through and rewrite this to trim the white space ourselves if you want to see that, rather than just leveraging what's already in the language. But I'm just doing this just so we can see how you use a function inside your for loop. So my function is called trim white space, and all it does under the hood is leverage what's already built into a string method, which is totally valid to do something like this. So I need to call, I need to call trim white space by its name. So trim white space, and you use parentheses. This is how you call your function. But I need to pass it something. I need to pass it a string value. And because org on the line above is an object, and I can access it by the keys, I can get the string value by the key name. I can pass it the name here, but that's not enough. When I call this thing, it's gonna return me the result back to line 23, but I've told it to do nothing with that. So maybe I need to store it like cleaned. We'll call it cleaned name because we cleaned it up, right? We trimmed off the white space. So now we don't have to store it in a variable, but I'm going to on purpose. And now we can console.log the cleaned name. And maybe I should have done this too. Let me prefix this. Original value, because in my head I know what this value is going to be, but you can't see what's in my head. So let's and we'll call this one clean value. And now cleaned name is that one. So we run this. You'll see that it happened multiple times, right? We called the console.log is happening 2 times per item that's in this array. So yeah, we have, oh, sorry, there we go. Sorry, I was like, where's the other one at? So we have original value, code platoon. You can't really see, the white space characters, I guess, here, huh? Did I put, maybe if I get rid of this, it'll stack it right next to it. That's not a good way to look at this. Strings are not a good way to look at white space characters. There's another thing we can do. So I can actually, we can pass multiple parameters here to console.log, just because this isn't showing me what I would like to see. So strings have an attribute on it. If I say org.name, I'm accessing that string value that's stored to that key value pair mapping up here, right? So I'm accessing, I'm accessing this value right here. What is that thing's length? So I can chain things to it. So org itself is an object literal. When I say org.name, this is a string. So a string, I can say dot length against that string. And this is how you can like chain attributes or method calls to your things. So the thing that comes out of our function is a string. So let me do cleaned name dot length. Hopefully that makes sense. And now we'll see that the length of the string has changed because we trimmed out the white space. And if you want to, you can go in and like, I mean, XYZ is probably the easiest one to tell because XYZ is 3 characters long. I added a bunch of white space characters, right? So I added 7 extra characters of white space, and trim did its job of trimming it off down to the proper length. And that's just and this is basically how you can like loop and call Deborah, I know you wanted, I think this is what you wanted to see.
Yeah, thanks. Yeah, and I guess I was also wanting to see, I guess if you have some extra time, some examples of like creating a loop starting with a function. I guess some examples like that.
So here, let me start out this way. I probably wouldn't.
Maybe not with this one, but maybe with another example, like creating loops starting with functions and stuff like that. Like a loop counting in reverse a number, numbers like starting with 10 and counting from 10 to 0 in a reverse order, starting with a function or something. I don't know.
Yeah. So just so you know, probably don't do something like this. Mostly, if you're trying to do something like this, it's probably not working. Or maybe it is. I'm actually, maybe it is.
Or can you do that? I was just wondering if you, because some of these challenges, they want you to solve a problem with a function.
Yep.
Yep. And I'm just, I guess, trying to figure out how to do some of these challenges with a function.
Yep. Yeah, you can write your own. Basically, a function is for you to write reusable logic. And this whole time, like anything I've written outside here, I can also do inside of I can put all of this logic I've written outside of functions right here. I can place this inside of a function for it to happen when I call it. So yeah, we could do something like function. You said count down.
Yeah.
Let's like I can count down, and maybe I want this thing to count down from any number I've ever given it, right? Like I give it one single argument where I'd say like the start num, right? Like that's what I'm gonna start number. We'll call it that.
Mm-hmm.
And if whatever number I give it, it's always going to count down from that number. And then maybe we are going to decide as a group, it's going to stop at 0. When it hits 0, it's done. It's not going to keep going. We don't want it to go negative, but we want it to stop at 0. So yeah, we can write a function that says, all right, you're going to perform a countdown for us. And so the body of our function will end up looking like beginning count. Like if I want to see output in my console, I'm going to put console.logs in here, and then let's say that's the start of what's going to happen, and then this is the end, and I'm going to put everything in between it. So countdown completed, right? Mm-hmm. Or we could put blast off or something, I don't know. But in between here, let me comment this stuff out real quick, because I don't want it to interfere with what we're about to get when we call this thing. So my function is defined above. At the moment, it's not, it's just literally going to console.log, but I can count down, I can call this and give it like a number. And if I run it, it does these 2 lines, right? Mm-hmm. Right? And I can call it a lot of different times with different numbers. So I'm calling it 4 individual times, mm-hmm. which means that this, when I call it here, this execution that happens, it's going to come up here, it's going to run these lines of code, and it's usually functions return things back to the line that called it. So as JavaScript comes from top to bottom, it's going to perform this code. It's going to run that code and give something back to this line. But right now we have told it to, right now we're going to get this because we didn't specify that long. We didn't specify the return value, so we'll probably get undefined back. Undefined is going to come back because I'm not returning anything. Anyways, each one of these lines is going to repeat that same logic. We're just reusing what we've written right here, and that's what functions are for. So you can write a series of steps that you want to perform, but you want to be able to call it from anywhere in your code at any point in time. You want to be able to perform this countdown, maybe. So maybe I want to count down with 10 or 1 or 2 or 3, whatever it might be. You can imagine like this is attached to like maybe a web page, right? You have a form page where somebody can like input a number and hit start, and your JavaScript will run and it will do like a proper countdown, or maybe a timer. Like you can generate a timer of your own if you wanted to. So if you want a use case for this, we can invent our own. So I can perform my loop in here the same way I always write a loop. This loop almost always looks the same way every time, except now I'm not going to dot length anything because I'm not working with a string anymore. So data types matter, right? This start number argument that's coming in is going to be a number type. So this 0 is a number type. I can do comparisons with a number type versus the number type, right? So I can say, actually, we can say we want our start number to be our top number, right? And then we want to count down from that number. So we could say the number that's passed in is gonna be I. We could say that. Does that make sense? Like we're setting I equal to whatever the start number is.
Yes.
And then I say, this condition now has to change because instead of starting from 0 over here, this condition that we have to write has to follow that. And so let's just give an example because it will be easier to follow. Let's say start number is starts from 10 for everything we're going to write. I'm giving myself an example just so I can finish writing this code, and we're going to just use 10 as our reference from now. So let's pretend that start number was 10, so I becomes 10. So I needs to be greater, maybe greater than or equal to 0, or maybe we could say greater than 0. This is going to have two different effects, but for now, let's leave it greater than 0. Just, we'll fix it if it's broken. So this actually changes the for loop. So because we need to start from a higher number and go down instead of start from a low number and go up for indexing. We're starting from a high number and going down, right? So instead of doing I++, I can do I minus minus to do decrementing basically. So if start number was 10, here, let me do this in comments again. So if I is equal to 10, the first time my loop does its first pass, its first iteration, I minus minus is going to make 10 turn into a 9. So after the first time the loop comes around, and then the next time it goes around, it's going to turn it into an 8, and it's going to go down progressively, right? So until it hits until this condition right here, I is greater than 0, until that is false. So the moment that I, which is when it turns to a 0, when this statement happens right here, when I is eventually that, it's going to be false because 0 is not greater than 0, it's equal to it. So that makes this comparison becomes false. And if you're tracking all of this so far, if all of this logic so far is pretty straightforward, then we can use I as our number that we just keep an eye on the whole time. So we could say like t minus I. So, and if I run this, because I don't really have to return a value here, the function's gonna always console.log prior to the loop, console.log after the loop, and then console.log inside of the loop, each step of the way. So it's basic, and I'm going to take these out because there's going to be a lot of stuff that comes out when we do 10. So let's run it, and you'll see that before the loop starts, we get our beginning countdown, right? And then I is starting from our start number, which is 10. So our very first iteration, we get t minus 10, right? And then I minus minus decrements 10 to 9. So it resets I to a new number value. It says, all right, I, now you're going to be 9. And we're going to run our code with I as 9. So, and then it comes back, it's like, all right, the only block, the one line of logic I have inside my block, this is, there's not a really good way to highlight, I guess. Everything that's between these braces is what runs, right? Everything in between this block. Our for loop is going to run and execute this code however many times. So for us, it's 10 times. Actually, it's, you know, if you count down from 10 to 1 or 1 to 10, do we want to include 0 is the question. So, and if we did, we'd have to say equals. And now we can include our 0. I don't know if that makes sense, right? So, and it doesn't just have to be a countdown. It could be, we could be counting up or counting down, but the way we have it written, this function is always going to perform a countdown. So I could say, we have this function now. So let me put it in our.
Thanks for doing that. Can you put that in Slack?
Yeah. I'm gonna put it in. I'm gonna put it inside here because. I'm gonna comment these out. So I just want you to see what happens because countdown console.logs things already. It already knows it's gonna do console.logs. So now we're inside of a loop, and this countdown is also gonna do a loop. The function itself is going to also iterate. That's its job. Its job is to receive a number, iterate, and console.log things, right? So, but we're also inside of a loop here. And this is where things can get tricky when you're doing loops, where you have functions that perform loops, and you're inside of a loop calling that function that is doing a loop. So it's, if I want to count down 10, let me reduce this. We'll do 3, because I already know that this block, again, this is a for loop. It's going to execute this code for as many items are in this length, right? This one is counting up, and this one counts down the way they're written. But this outer loop is going to run for however many items are in this array, which is 3. So we expect that countdown is going to run 3. It's going to be called 3 individual times because it's inside of a loop. That makes sense? Which means we're going to see countdown beginning 3 separate times and countdown ending 3 separate times. And it's going to, we have a hard-coded 3, so it's going to do it, you know, if we scroll up, you can see the beginning of the countdown. Oh, wait, I have old data in there. Let me see. All right, that's better. So I had to clear my console out. So beginning countdown, it goes 3, 2, 1, completed. That was our first iteration. Basically, we were on this item, even though we're not using it, we were on this item for this block of code right here. And let me, this is kind of hard to see everything at once. So this loops 3 times, if that makes sense. This is going to be called 3 times. Yeah. Does that make sense?
Yes.
Yeah, okay. So yeah, so we're calling it 3 individual times, and you could create your own functions to perform work like this. And console.log isn't something you don't always have to do. A lot of times you want to like return something, but obviously we needed the output to represent this countdown. Otherwise it would have been meaningless to like run a function and then have it return 0. You're like, okay, well, did my countdown happen? I just got a 0 back. I guess it happened. But yeah, if you want to see your output, console.log will do that for you. Sorry, we kind of strayed away from object literals a little bit into functions, but you can pass, I guess, combining this knowledge, we could pass this entire object to, I can alter trim white space. I can say, all right, I don't want to explicitly pass in the string myself. Maybe I want to just pass the entire organ, and it will give me back a cleaned version of the entire organization, right? Like maybe these are also like uncleaned pieces of data too, right? So maybe I want this function to not just be trim white space, but maybe instead I want it to be called like clean org data or something like that. And then I'm basically refactoring my code now to match the same terminology. So cleaned org, and then I'll get rid of this console.log cleaned org. So I haven't set this up yet, but we're just going to go up here and change this name now to clean org data. And instead of a string now, we're going to pass it, we'll call it an org. I'm going to put obj to like suffix what data type we're working with in here. So now, if I know that I'm working with an organization object, and I know, now I can customize this function as deep as I want to go. If I know that my organization has two attributes in here, name and type, right? I can say, all right, I want to create a brand. Maybe the thing I want to do is return back. Here, let me do this across multiple lines. We'll call it cleaned. I don't want to make the naming confusing here. We'll call it new data. And the thing I'm going to do in here is say, here, we'll do it a way you haven't seen yet. I'm going to have an empty object. That's how it's going to start out. And then now I'm going to say, remember how I did city state and I set my own key to whatever I added data to an object? We can do the same thing here. So I can say, all right, the organization object I passed in, org object, ooh, this is not a good way to do this. I basically need to, I would have to hard code these in, I guess. I would have to physically say name, which isn't, it's not terrible, but I don't know if anybody's noticing around, this kind of creates a problem. Like I'm totally making an assumption that these are exactly what they are. So if this structure ever changes, I have to come in here and update this function to match. So right now I'm kind of like hard coding in the keys, but for what I want to show you, it's fine. So I want to talk to this incoming object. I know it's going to be an object literal, so I can say .name, and I could trim that white space. I basically am creating a brand new object literal for the sole purpose of cleaning the data off of it. And then I can return that new piece of data. Hopefully that makes sense. It's not doing very much. This is a very contrived example, but I'm basically passing like what might be bad data. And I'm saying, hey, function, I want you to perform these specific steps to my piece of data, and then give me back my more ideal piece of data. And so when I say this, any one of these orgs that I'm iterating over, all of this bad data, as I iterate over it, I'm going to pass it to my cleaning function. So I'm passing an individual org into that cleaning function, and it's giving me back a return value that is a brand new object with the clean data in it. So this isn't going to show in the console as I want, but actually it is. It does show it. It highlights it in green. Am I still calling? Yeah, there we go. So had I console.logged, or here, let me do this. We could see the old value compared to the new value, and I'll do a separator in here of like nope, I'll do it down here. I'm going to separate each iteration from each other. So let's do like equal signs, right? So now we can see I've console.log and I separated each one. So I can see the original value, the first console.log right here, right? It has the white space in there, the bad data. And then I can look at my clean data that my function ran, line 30. I can look at that one's value that it gave me back, and we can see that my cleaning process against my own object literal happened. So this is how you can kind of like pass your data into customized functions and then return back the same data that you did something with, like you generated a whole new piece of data out of it. You actually do this a lot in data science or even web development. You can get form data from like a user. They're submitting like a contact form or something, and you never know what a user is going to input into forms. But when that data comes in, you might be mapping it to something that's like an object literal, like the subject, and then a string value of what they put for the subject or something like that. So I'm just trying to give you examples of different pieces of data that you do that with. All right, so I think I've gone over my hour of talking, and we have, when do we end at? It's 9 usually, right? So I kind of want to let you go and let's see, what challenges can we do? Objects. All right, so if y'all want to give any of these a try, I don't know off the top of my head which one is more difficult. Car and miles. And I'm just checking out one of these challenges to see if I covered enough that it will be good enough. Write a function that takes in a car object, takes in a car object and a number of miles driven as an integer. Update the car object to include the new amount of miles in the odometer. So they give you a function called car trip. They expect a car and a miles. So
can we do it together?
Yeah. I kind of like to release folks to work on it, but if everyone would rather just go over it now and then work on it, I could always do it now. We could always like go through a problem now and then just release you guys for the night, I guess. And after that, because I don't know how long I'm going to talk for on one of these. I know I kind of go over, so. Why didn't you need to return statement in the countdown function? You don't, it's not necessary to return. It's usually a good idea to return from a function that you're creating. So like this one, I wanted to clean and hand back the new data, but in my other function, oh, I got rid of it. My other function was just console.logging, and I didn't need a value to come back out of a countdown, because if I'm counting down, it's always going to be 0, unless it fails somehow. But console.logging output was more relevant. So what would y'all prefer? I guess, what's the consensus? You all like working on your own challenge, taking some time, like 30 minutes or something, and then, well, what time are we at? It's 5:30 for me, 7:30 CST. So we got what, an hour and a half? So I could release y'all for 30 minutes to go, or 45 minutes to go work on challenges, or we could just go over a challenge now, and then y'all can just take the rest of the night to work on the rest of the object challenges. So yeah, just throw your vote in the chat, I guess. We can flex this whichever way people prefer, but or we could do both. Yeah, whoever doesn't want me to spoil the challenge can hop out of the call and come back in a half an hour maybe, and anybody who wants to go through it can stay in the call, and then I'll leave the call up until our usual time. So I'd like to walk through it together. Jeremiah wants to too. And give input. Yeah, we can like slowly work through this thing. And whoever doesn't want to, you can hop out, and then yeah, if you don't want me to spoil it, I just don't want to spoil answers for people, because once you see it, it's hard to unsee answers. So car trip, is that the one y'all want to see, or I don't want to, or maybe one that has loops in it? I don't know. Yeah, if y'all have a preference for which challenge for objects, we can do that. Write a function that takes in a string of lowercase character. Wait. Returns an object containing the count for each. This is a good challenge. I've done this. I've done forms of this. This is an interesting one to do. So whichever y'all want to do, car trip, number of characters. I kind of want to try to keep it to one of these one that says objects in it. So if anyone has a preference, just shout it out or throw it in the chat. We can do that.
One that has objects and loops in it.
All right. Yeah, I mean, we can do this number of characters. Oh, not this one. Number of characters. So we have to loop for this one. Number of characters. Yep. Yeah, we can do this one. All right. Sweet. Well, let me drink a little bit of water. All right. So I'm going to copy this because I don't want to jump back and forth between the README screen. And again, fork every time. All right, so we'll throw this. I did not throw this. You want me to, I can throw this now or at the end of class or something? I don't know if you were wanting this, whoever was asking for this code.
Now?
Yeah, I can. Yeah, I guess I can, I'll just throw it as is, and if any of the instructors want to criticize me later, it's fine. All right. They're not the best comments in there. You probably could be better, but I think you just probably want the code so you can
maybe later then
test it. I mean, I can always add or edit it later. Yeah, later. let me touch it up a little bit, and then I'll ping it in Slack as a snippet, and you can take it and mess around with it. All right, so let's hop into this real quick. So again, this is the ES6. Before we start, this is the ES6 syntax for writing the function. It is the equivalent of me saying this, just for a quick translation. This is the same thing. Like, this is exactly that. It's a function, in case that's not clear. I'm going to leave it how they have it, ES6 syntax. This, just know that this is a function still. So that's not confusing. All right, write a function that takes in a string of lowercase characters. So it's already trying to give us some hints on what the incoming data looks like. And I'm going to take this line right here and just throw it at the bottom, because this is kind of our test case. This is already one piece of given input and expected output. So I have, if I pass this to my function, I should get this back. That's what this whole line means right here. So I'm immediately going to call my own function so I can test my own result. Right? I want to see my return value, and that's what I'm doing right here. So immediately I'm just going to put these two lines, because I know the moment I run this, if I run it right now, it says undefined, because I don't have there's no body of this function defined yet. It doesn't return anything yet, but I'm just prepping what I'm going to have to do at the end anyway. So, and this lets us test it every step of the way. So I can run, having these two lines is going to let me be able to run this code and see results immediately in case I get stuck. So write a function takes in a string of lowercase characters that looks kind of like this, and it returns an object containing the count for each letter in the string. So yeah, so we need to map out our steps for this. And my thought process immediately for this is I'm going to have to loop over this string. We could treat a string just like an array. We can we can index an array and we can index a string. And just to prove that we can do that, do you want me to stick with the same style of loop?
Chris, can you move your screen over? It's getting cut off on the left side.
On the left side.
Yeah.
Weird. That should be showing my entire screen.
And then also, is that fat arrow? Does that fat arrow mean function?
Yeah. This is the ES6 the JavaScript ES6 syntax. It's like the new way to write a function. When you said it's getting cut off, I guess I can't tell what you see right now. You can see all of this, right?
It looks great now.
Oh.
Okay. Yeah, right there, it's gone.
That's weird.
Okay.
Okay, so I'm gonna write this for loop the same way. I don't want to keep changing it on you, but there's a lot of different ways you can write this for loop. This is just one of the ways. So string is gonna be the string data type. I can call .length on a string, and I can do the same I++. So I'm treating I as a way to index, and just so we can see the results of this, if I say string I, and this is my function call, right? So this line 15 is going to call this logic when I run it. So at the moment, I'm just testing that this works. This loop is going to work. And it's individually, it's console.logging every single character on a separate line, right? It's iterating over a string. So you can iterate over a string, which is good because I need to be able to access each individual letter for this to work. Because if we think about this, I'm basically trying to create a mapping of, if you notice in here, the first thing I notice is B is in here and it's mapped to 1. And if I look at my input data and I went through it iteratively, like left to right, I go B, we have 1 of those. And I'm going to do this the slow way, right? So I'm going to go through the whole thing. There's no more B's. So B is 1. And then I'm going to also look at this and say, all right, this next character is D. But if I keep going, there's 2 D's. There can, like, object literals, I said this earlier on, the key is unique. So there can only be 1 that exists inside of there at a time. So that might be something that we have to account for. And then A, there's 3 of them. And we're basically needing to like iterate over and keep track of every single one of these characters. And from our result, it looks like each character needs to be its own key. And then each character needs to hold the proper count mapped to that key. So that's the thing that we're trying to build. That's the logic that we're trying to build from this. So thinking this out loud, I kind of jumped ahead. I wrote a loop already. So let me get this out of here. Let me get the console.log out. I'm just going to leave the loop because that thing's going to look pretty similar each time we write it. So the first thing I need to do is iterate over my string. And iterate's just fancy words saying I need to loop over my string. Well, iterate over my string, or iterate over, I think it would be better if I said iterate over each character of my string. And that's step 1. I know I need to do that because I need to individually look at each one. But I also kind of need to store like this historical record of what I've already seen before, right? Like I have to know when I go through this as a human, it's fine because I can kind of like, this is short enough that I can probably remember what my mappings were like, but this data set can be huge. But I need a way to start out with like an empty value, right? So maybe my first step doesn't need to be iterate. Maybe that's my second step, because my first step, I kind of need to initialize a starting point for our object literal. So I basically want to say, initially it's empty because we haven't looked at the string yet. And then when we encounter the very first character, we're gonna refer back to this object and say, hey, does a key with this letter exist? And it's good because I actually kind of covered this, didn't I? Does a key exist inside this object? So I can actually use a very similar line to this to check for containment. And so, okay, let me back up a little bit because I think I'm just kind of jumping around here. So first, I need to initialize a starting point. Our object needs to start with nothing at a starting state, and then I know that I need to look at each individual character. So I'm gonna have to like iterate over each individual character, and then step 3. If I have access to each individual character now, I can ask the object in question, so the object that has the blank initial state, and will hopefully at the end of our loop, we'll have a state that looks like this. So initially it's going to be blank, like that, and then by the end of it, it will be populated with the value, like key value pair mappings. And that's what our end goal is, to try to get this result. So we want to ask the object if it has, I'm debating if I want to leave this out on purpose or not, just to show you what happens if we were to, if we skip this step, because I feel like a lot of people might actually skip this first step. Maybe we can, I'll just do it. We want to ask the object literal if it has the current letter, or I'll say character. Our character is just going to be one letter out of our string that we're currently on. So let me put number 1 down. So because I know I'm going to have to do this, and I want this to be more obvious for you. What do we want to call this object here? Oh, let me get my chat back up because I have chat. I'm probably missing body. All right, so yeah, my water is water. Don't worry. We want to initialize this object to empty, and I'm just trying to figure out a name to call this. And if I usually can't think of anything, I just start with result, and maybe we'll change it later to generic. Result is the thing I always end up returning, so I'm just going to generically call it result for the moment. Result is our object literal, the thing that is going to hold all of these by the time we're done with this loop. So I'm going to draw this out longer than I need to, as usual. So hopefully it will make sense line by line as you go through it. So I'm going to call this character. I'm going to call it, I don't think char is a keyword. I don't think it's a keyword at all. So char, I'm going to call this thing char, and it's going to be string of I, if that makes sense. So it will be a representation of like first iteration. It's going to hold our first letter, right? So char will be the first. It's going to hold each of the letters one at a time, if that makes sense. And then I don't have to do that, but I'm just storing it for now. And the thing that we want to do is kind of like what I had in the slides. So I want to ask the object if it has that character, because if it does, I need to add 1 to its current value that it has. Otherwise, I need to set it to 1 because we've just now encountered that character, right? Like whatever this character is, we are either just now encountering it or we have encountered it before. Because if we're iterating over it, it either is just now being seen or we have seen it before. That's the case that we're really counting for, is have we seen this character before? That's the question we're trying to ask. So char is our key. Even though this is blank, we can still say, hey, object, do you have a key? It's going to say no for everything because there's literally nothing in there right now. So I can say, I'm going to call this result object or obj. Maybe that way it's clear what this type is. So char is just a 1 character string. Is that key inside this object? If yes, we want to increment our count contained in this object. That means if it found it, that means there is already a value in there. We don't want to reset it. We don't want to accidentally say like set it equal to 1, because if there was already 1, we would be setting 1 to 1 and we would never increment it. We would get stuck in this, like everything would just end up being 1. But I'm gonna not write the logic for it yet. I'm gonna put the else, the other side of this condition. There's always, when you have an if statement, there's always another side, right? And it's gonna be when char is not, when this character is not in our object, what do we want to do? If no, we want to set this to 1. Does this logic make sense so far? Is everyone tracking so far? I'm gonna pause right here for a moment just so.
Yes.
Okay. Yeah. So I'm basically trying to ask. Yeah, I'm basically trying to ask if B. So if B was already in here, if I initialize this thing to where it wasn't empty, and then this statement runs, if char is B, then this will be yes, like because B will already be in there. So the thing I don't want to do, I don't want to do this where I say char. Remember I had that thing where I said I can set, like if I did something like this, right? This would set B to 1. Every time we see B, the letter B inside of this object, it's always gonna, this would make it always be 1. It's not what we want. We don't want this to happen. We do want this to happen, but we kind of want this to happen down here. And I'm just placing B here for our first iteration example. I'm not going to leave it hard-coded because char is what our current character is. So B, I'm just using a value so it's clear what's actually being referenced throughout this code right now. So I want, when B is not in here, right, when there's nothing, and this is the first time we have encountered this character, I want to say, all right, I've encountered it. It's at least 1. Like we've encountered it 1 time so far. But if it does exist, that means we have already encountered it at least 1 time, but it might not be 1 time. It might be like 10 times that we've seen it now. So we want to take that value, whatever it is, and increment that value by 1 more time. So result object, if I know what this is going to, well, I'm going to have to use the bracket notation for this because I need to pass in, I don't think I can do that. I don't think that's a thing. Dot syntax. I don't think I've ever tried to do it this way. So my go-to would probably be this, because I know that I'm passing in char into the brackets and saying, give me the value to whatever this character is, because this condition was true, which means this B right here, oops, this B was in there. If this statement runs, we know that it exists in there. And this is how we get the value out, right? Like this is how I access by the key name, the value. This is going to be char. I can't hard code it to B because that will only ever work for B alone. So char is going to be whatever character it is, right? Gives me the value out of it. I want to take that value and add 1 to it. But I also need to do the same line, char, and set it equal. Basically, I'm incrementing, right? Like if if we had a variable that already existed and we added 1, this doesn't set that variable equal to that. But if I did, I know I did this in a previous session where I said, whatever my variable is, it's equal to the current value of that variable, and then add 1 to it. This is the long way to write it, and I'm going to leave it like this just so hopefully that's clear. And increment that the existing value by 1. It's basically what we're doing on, I'm going to put it at the end of the line. Increment the existing value by 1. So if I do this, this is a lot of code to already write without running it yet. I kind of want to run. I am altering the behavior right now. So let me see. I need to come outside of this loop. Actually, let me throw some cons. I think maybe the best way to like see this I love to console.log things. This is how when I started programming, I console.log everything, or not console.log, but I did the equivalent of a console.log in whatever language I was working in all the time, because it kind of helps you visualize what's happening. So we can console.log. We already did char, and it printed each character on a separate line. Let's do a console.log based off of the condition. So char, and I'm going to put like, I'm trying to be too clever with this. Let me say char and then was in result object. And then let's run this one. Char was not in result object. And I kind of want you to see when we make this call and we pass it, 1, 2, 3, 4, 5, 6, 7. It's a 7-character string. This is going to be 7. So we're going to iterate 7 times. So I should get console.logs to match this iteration count, right? So let's run that. All right. So and something interesting happened because I left a piece of a hard-coded B in here. B only happens one time, right? It never happens again. So we only see the console.log happen one time for it. It wasn't in there. We set it. This is just like something on accident I left, like a hard-coded logic error. I don't want this to be B. I want this to be char. I want it to change with the current character that we're currently on. I don't want it to just stay B forever. So if I rerun this again, so now we can see something different. If we it's going to iterate through this in the order that the string is in, right? So, and if we think about this out loud, B, we're starting from an empty set, right? So each time we're asking if our character is in that set. So keeping that in mind, B, this is iteration 1. I'm currently looking at B. I have an empty object literal. B is not in there. So I said B was not in there, but I'm currently, I'm proactively setting B will now exist inside this object. This is mutating our object. At this point in time, there will be a B with a 1 in here now. Whoops. Or it's really going to be like whatever that char currently is. Anytime this else statement runs, we're basically setting that key to 1 when it doesn't exist. So if that makes sense, right? B only happens one time. It's set to 1. We don't have to worry about it again. We're never going to have to perform a lookup for B again because it just only happens that one time. But the loop is going to go to the next character. So D, it's going to do the same thing. It's going to say D was not in the object. It's going to do the same thing it did for B, right? So initially we had B. And so D runs, and now D is set to 1. And then the same thing is going to happen for A. So now A is also set to 1. And then, so these first 4 letters, it hasn't repeated a character yet, right? So each one of these is going to start off as 1. And then finally, when it comes back to this D again, so on our 5th iteration through this loop, it's going to say, if D is in our object, and that's what we're looking at right here, it says, oh, hey, yes, there is a D in here now. And it's going to run this line where it says, take your existing value, which is 1, and plus 1 to that. So make it 2. And it's going to be this equal sign right here is going to set this 2 equal to that D, right? So D is going to be equal to 2 now. And this is kind of like slowing down our iteration loops step by step of like kind of the logic that's happening here. So on our 5th iteration, D becomes 2. Oops. Let me back that up a little bit. So yeah, D becomes 2, and then the same thing with A and A. So and then the loop ends after that second A. So A, it comes through, runs the same logic, says is A in there? Says yes, it's basically currently at 1. This is going to increment it to 2 the first time, and then the loop comes back around, and it's conditionally running one of these 2 options, but not both. So that ends up being a 3. And I kind of like manually went through these steps as I'm looking at my code. So I should have B is 1, D is 2, A is 3, and C is 1. And B is 1, D is 2, A is 3, C is 1. So that is what it's telling us that we should expect. I think I have all the code there that should make this run, but I haven't done one thing yet. If I were to take these console.logs out, we can see our actual result. It says undefined. That's my fault. I didn't put a return value, but let me be extra obvious about what I'm about to do here. You don't want to return inside your for loop. I mean, there are reasons which you would when you're like trying to search an array or something like that. But we need to go through every character, which means we don't want to end this function too soon, which means let me pull this down a little bit. I need to be able to make it through, I need to be able to make it through this entire block before I return. So my return statement needs to be outside of the loop. And the thing I want to return is this. Like my for loop has been mutating this object the entire time, right? Like I have been assigning values to this object literal the whole time. And I can actually emphasize that a little bit more because maybe I feel like I might not have done a good job of emphasizing what this does. I'll do that. That shouldn't take too long. So let me run this. And I get back an object that says, this was our expectation. So B is 1, yes, B is 2, A is 3, and C is 1. So this is correct. But why stop there? Let me, what if I did triple A? I should only get back A is 3. And that's what I get. So I'm kind of just arbitrarily making up my own values here. So it looks like it's A, B, B, C, A, B, A, C, A, B, B. It's cheat code. If anyone's familiar with that one. So there's 3 A's, 3 B's, and 1 C. It looks right. All right, so it looks like it's working. But let me emphasize this real quick because I don't think I touched on this very much. And I'm gonna do it right here this is a JavaScript console, right? So I can do JavaScript. It interprets JavaScript for us. Let me do this. So I have a result object, right? Same thing that's in my code. whoops, result object. If I put a B in here like this, and then I ask that every time, and I ask that object, what's in there now, right? I just assigned a key and a value pair. This is my key, that's my value, and it makes it a pair now. So now I can ask object, I can say like B in result object, and it says true. All right, well, what about A? False, right? So just with that right there, you can see that oh, let me do that too. Let me do that line specifically, line 20. If I say, basically the for loop is doing this automatically because we're setting the char to whatever the current char is. So let's pretend our current char in the console down here is, sorry, I'm trying to make that bigger, is B, and I do equals result object B again plus 1. So there's two operations happening. It's going to run the left side first, the left side of the equal sign, and it's going to do, it's basically going to do this operation. It's going to say, all right, add 1 to whatever value is inside whatever this key, the value for this key is, basically. So it's going to grab whatever that value is, add it, and then it's going to take that value and assign it back to what we're currently already looking at. So if I run that line and then I ask object what it is again, now it's 2. And if I keep running this line, it will keep going up each time I run it, right? So basically our loop is doing this every time it encounters the same character in that string. Each time it's going to run that line, and then that's the new value, and it's going to run that line, and that's the new value. But when it doesn't encounter a key, when it encounters a key that does not exist, so like C, this has to be in a condition, because what happens, first of all, what happens if I do result object C? It says undefined. What happens if I try to add 1 to a C? It gives me NaN, which is a data type, not a number. It says it's not a number, and that's, thanks. Undefined plus 1, the operation of adding undefined to a 1 gives you a not a number. So what would happen if I didn't have this condition protecting our assignment, right? So this condition is our protection. Like, I only want to do this operation if there was, if it was assigned a 1. So this else statement runs for all the initial cases. And then anytime there's a repeated case, this condition is running. So it kind of looks backwards, right? Like else statement runs for any new value. And then this upper statement runs for any existing value. So I know that if the value didn't exist, it didn't start off undefined, right? I'm not trying to do that. That would give me what I don't want. I am initializing everything to a 1 if it didn't exist. So that's how that's happening. Hopefully that makes sense. Hopefully this whole thing I just did in the console made sense. We're working with an object literal, so I'm talking to it. So my else code is basically assigning the C first. Now I should have 2 in there. And if I talk to C now, and if I just did it this way, I do get a 2, but I didn't reassign, so it still thinks it's 1. And that's why this whole line has to exist in the first place. That's why I have to do the assignment operator, the equal sign. I am reassigning the value that this key holds reference to back to itself. I'm basically updating. I'm performing an update. Yeah. And if we just look at the object, now it's 9 and 0. Hopefully all that made sense. And does anybody have questions on any of this stuff? Or do you want to see something, you have something else in mind? Or you want me to elaborate on anything else? Because I can.
Can you, thanks for showing us that. I was trying to do, this was, I guess, not objects, but there was one in the, one of the challenges where it says remove the zeros. It was I guess one of the functions. If you don't mind discussing how to resolve that one.
Yeah.
Because that was what I tried to do with that one. I was wondering, were you supposed to change that one before you resolve it? It gives you a number and it says remove the zeros. Were you supposed to change that to an array and then use slice on that?
Oh, I'm sure there's a.
I tried doing that, and I don't know. I couldn't. I got it to work with one number, but it wouldn't work with the other number.
Yeah. Yeah. So there's always multiple ways to tackle a problem, and there's multiple ways because you have multiple data types that you can potentially leverage, and whatever data type that you pick. So if it's a string that you're working with, there's a way that you can. There's a few ways you can approach it. Which one do you say it was? It was removing zeros?
remove zero types. It's I think it's under, I don't know, I think it's maybe under function. I think it's up above. It may be a little bit up above 24.
Oh.
Yeah, remove zeros.
Is that the name of it? Removes. Oh, here it is. Okay.
That one, yeah, number 9.
Yeah, sure. Yeah, we can go over. I can go over this. Let me make sure nobody has any more object literals questions first, because I don't think this one's going to be object literals. But this one is. This one says. It just says types. Write a function that returns a number with all zeros removed from it. Okay. Yeah. Yep. So this is an interesting. You're basically having to translate your data type to something that will allow you, you can't, these are numbers, like number types. You can't just remove the zeros in between the two. Like that's 1001.
Mm-hmm.
It wants you to get it down to 11. You can't, there's not going to be a good operation for you to get that down to 11 or, to strip out these zeros. It needs to be a different type. And so you can transfer from one type to another type, perform the action you want to do. Like you can strip zeros out of a string and then convert that string back to a number. So you can go from a number to a string back to a number and perform your operations that you need to do on the string, and then make sure that the thing you return back is a string converted back to a number. And we did go over some of those, like parse, like string has like parse int or something like that, but you need to convert it to like, you could do like a string or an array, and then because you can join an array back into a string if you want. There's a few ways. We can definitely go over it.
Okay, because I was trying to convert it to an array and try to do a what was it, a slice, and it didn't work.
There's a few ways to do it, but does anybody have questions on the object literal portion? And then if not, we can go over that challenge too. I think I have enough time, or we can, because I did this because we went over this challenge so early, I can actually end on this stream, and then I can stick around for a little bit and help break anything else down, or people can take off because or we can do another challenge. It's really whatever y'all want to do. I'm here until for another 50 minutes. So
well, let's go over the zeros.
The zeros. All right. Yeah, we can do that. Do you want me to record this? Maybe I can record it.
Are you going to put that one in Slack? The object one?
Yeah, I can put this in Slack. Let me touch up some of the comments just so.
Oh, were you recording this whole thing?
Yeah. This is recorded. I just don't know if I want to mix and match object literal recordings with a challenge that's not related, or maybe it's still all right. I don't. Maybe it's fine.
Do you want to do a challenge that's another object? Is that what you're saying?
No. It's fine. I'm gonna stop the recording right here, and then maybe I'll just record it separately and make it available another way. because I almost don't want to mix and match these challenges. And maybe it's fine. I'll just keep recording and whatever, it's fine. It's not going to be a big problem. Whoever's going to review these videos eventually will probably find it useful, or if they don't, they can just not watch it. All right, so yeah, let's go over this one too. If everyone's if I haven't melted any brains yet, it seems like y'all are still willing to go with some more challenges. Let's do it. Remove zeros. All right. So immediately when I looked at this, I kind of laughed because, you know, the first thing you see, they're passing in a number type, right? And they're expecting back a number type. And it makes you think initially, like, you don't have to, you can just work with this type the whole time, which isn't true. It's like, we definitely don't have any good methods on a number type that's going to let us just strip out a certain number of zeros. Because if you think about it, every zero has a place in the number, right? It makes it what the number is. So 1001, if I strip out a zero, that becomes we don't know what place we're stripping out, so we can't. There's not like a perfect math equation. I don't think there's a perfect math equation, at least not off the top of my head that I can think of, where if I know where the zero's at, I can like subtract that many places or something. But we can't index a number. Like I can't. Here, let me let me show you what I mean. I can't index a number. But if this was 1001 as a string, I can index a number that way because it's a string. It's a string of characters together. But yeah, so 1001 is just 1001, and I could say like, yeah. There's no good. I can't think of anything math off the top of my head that could. Maybe someone's a math genius in here and has some algorithm that they could apply here, but we're definitely going to do a translation of types. So let me copy this over. So comments, write a function, returns the number with all the zeros removed from it. Also, this is the way I'm trying to do this is in a similar fashion. If you ever apply for jobs, and even with the cohort, when you do work on soft skills at Platoon, if you're doing like the full-time course, they work on soft skills. Like you literally practice how to do challenges like this. And they try to make it like an interview setting where they're pretending to be an interview and you're the, interviewee. Like you're the one. They're going to give you a prompt like this. They're going to be like, here is a challenge and solve it. And then you're going to have to like basically do what I'm doing with them and kind of like talking. If you can do what I'm doing, like talking out loud, you'll probably do fine on all the interviews, even if you fail, even if you don't get the answer. That's not always the case, but if you can talk through your logic and get most of the way there, it's usually fine. So exactly what I'm doing is kind of how like interviews happen. When they give you a challenge to see if you want to pass any part of the interview. This is like one of the things that they do. See. And talking out loud. So I'm reading the prompt, right? Write a function, returns a number with all of the zeros removed from it. And then you try to understand the prompt before you start writing any code and maybe think about the steps that you want to take here. And this is all depending on your experience level. You can just start off with assumptions the whole time. So I know that the incoming thing, the input is a number, right? The return value needs to be a number. So the thing I'm going to receive, it's going to be a number type. The thing I need to give back my result needs to be a number as well. So I need to return, some kind of number here. And this isn't proper syntax. This is just me just representing what I'm thinking. Oops. All right. So if I receive a number, I guess what's the first? How can I translate a number to a string? I guess That would be the first question for me. So
Parse.
yeah, so we could, I mean, we could say, yeah, so I think I want to, I want to get this into a different type because number won't work for me, for what I need to do. Different type, string maybe. That's kind of where I'm going for the moment. String might be the easiest one to use, and we possibly could use an array, and there's possibly a way to, it really depends on how I guess a good starting point here. Let me mdn parse int, because we've seen this one before, right? And we know that the thing that I want to return back, it needs to be a return of a number. And we know that parse int can change some kind of, we know that if we give it something, it'll try to give us back a number, but we need to know what do we have to give it, because that's going to like help us build out this road of, can I use parse int? So parse int is a function. It will take a string argument and returns an integer of the specified radix. Okay, so if you're not math, if you're not following the radixes, so we can come down to parameters and give us a longer definition of what that is. It's the base. So a base, computers use like a binary base, a base 2, and then humans use base 10, right? We count off of base 10. So we count up to 10, 11. All of our numbers go up to 10 and then up to 20, and we kind of go by tens all the way up. Everything is in tens. I'm not going to get too into explaining math because I probably am going to destroy definition of base. So the first argument for it is a string. So we know that if we want to use parse int, I know that I led with saying I want to use a string. Whoops. I know that I led with saying I want to use a string, but I didn't say why I want to use a string. And so I'm kind of working backwards now. I know that parse int is going to give me back a number. So far, my two examples, it's not a decimal. At least these two examples, they're not decimals. It's not returning any kind of decimal. They're whole numbers. They're basically integers. So parse int, I know that if I feed it a string, I can get back a number. And the thing I want back is a number. So that's why I'm deciding at this moment that parse int might be useful. But also, if I choose to use parse int, this also means that if I choose this, I have to now use a string, right? I have to pass a string into here, a string representation of a number. So that means my number has to be translated from a number into a string so I can perform an action and then call parse int when I'm ready to return it back. So I'm thinking that maybe, what if I returned parse int on my my result string? We'll call it result string for the moment. So I'm just kind of like prepping what I might put here. I'm saying I want parse int to be called. I want to return what parse int returns, basically. So parse int should give me back a number. So I'm just jumping ahead on that line, just and we're going to fill in the stuff before it so that can actually happen. So let me come back up here. My number, I want to get this into a different type. I've basically made the decision, like, I want to translate this into a string. How do I get this number that comes in? Actually, let's put it down here. And our expectation is 11 from that. So how do I get this number that I'm passing in as number how do I turn that thing into a string in the first place? Like I need to first get number to a string and then string to a number. That's my first goal. So if I don't know, like if I don't know about things, I don't know what exists, right? I'm pretending to be new. So if I Googled how to, I'm putting JS as a keyword, string, oh wait, no, number to a string. And I get kind of like a hint here, and geeksforgeeks.org, developermozilla.org. I kind of want to use this one because I don't want to rely on their answers too. I kind of want to force you towards MDN docs before you see anything else. So they give us an example that we can like physically run. It says num object, which is a plate. It's a representation. It's a placeholder. It should be a number, right? I can call a method called toString. I can potentially add an optional argument. So at first, we're not going to do anything with this. So if it's a number, I can say .toString on it. And actually, and to test my assumption, I can physically, remember how I said I can't index this like an array, right? But it says I can call toString. Can I say 1001 toString, not pass it the optional and see what that does? Nope, can't do it that way. That was my first assumption, but what is this type? Let's see how they use it. Okay, they said it as a variable first. That's interesting. So, okay, I think this is where it comes into JavaScript object wrappers is what this is. So maybe we do have to, in fact, set this. This is kind of weird. This is a weird JavaScript thing. So I'm just practicing in the terminal to like test my assumptions here. So let number equal 1001. Can I say number.toString now? It's okay with that. It likes that. So I successfully converted 1001. So if I say number, it's still a type. It's a number type, right? So it doesn't change it. It's not changing my variable. My variable is still an integer at the end of the day. But if I say toString, it's returning a brand new value for my line. So that's good to know. So my first thing I need to do, number is already a variable, so I can say toString, right? This should give me, let me fix, sorry, this is gonna get messy if I don't fix this now. We'll keep our code down here and let's pretend number is 1001, our first case. So number is 1001. So this is going to become 1001. And I mean, I guess, the question is, do we need to maintain the original number for any reason? Like, I'm just thinking about it. It doesn't seem like I will need any reference to that original number after this point in time. So maybe I can just reassign this, is my thought. Like I don't need this number right here anymore, I don't think. It's my assumption for now. Might be a safe one. So let me console.log. I'm gonna test my code. I'm gonna just test my code steps of the way, right? So I want to make sure. I'll just print it out. It should look like a string when it does it. So I'm calling my function, passing it a number data type. I'm converting it to a string. I'm getting it into a type that I can work with. I'm changing it from a number to a string. So I have, hopefully, we're gonna go look at the string methods and see if there's something that we can use for string methods that number methods didn't have. So I'm converting this type. I'm gonna print this thing out. And it says 1001, but if we do this, it says string. So type of will tell me like what data type something is. It doesn't work well for arrays. It just calls them objects. So something good to know. It works for numbers and strings well though. All right, so this thing is a string now. After this, after line 15, after that point in time, it will be a string. So what kind of string methods can I call on this thing now? So let's go to standard built-in objects. Maybe I'm just kind of going down to the S's to string. And we can just like eyeball these methods and see if anything like sticks out at us. Let's recap what we need to do real quick. When I have a string, I basically want, I want to get rid of those, right? I want to like cut them out or delete them from my string, or I really just want, if there's zeros in there, I just want them to not be there anymore. So what kind of string methods do we have that will let us do anything? So there's one in here called replace, string replace. I mean, we kind of
Slice?
Yeah, and there's slice too. So you have slice, yeah, let's look at slice for a minute. This method extracts a section of a string and returns it as a new string without modifying the original string. So if I give it, well, let's come down here. It says beginning, and it's the beginning index. I can pass it the index positions where I want it to slice. But if you think about that for a minute, if we have a string, right, like 1001, if I want to slice that, how do I know where those zeros are at? Like if for 1001, I can figure it out myself, but it's not going to work for every case, right? Like if I say, all right, I want to slice 1 to 2, I don't know if that might not even be right, but let's find out. If I want to slice those two out, what happens right here? Let's look at the behavior of this thing. It gives me back a 0. That's not what I wanted to slice. So it's slicing between a range. Like if I say slice between 1 and 2, it's giving me my range. So if I say 3, it's giving me 0 and 0. So it's saying it's starting. This is my starting index is 1. So we count from 0, right? 0 base index. 1 is the 0 index. 0 is the 1 index. So it's starting from this one and then slicing up to, but not including 3, which is that one. So it's actually slicing out this chunk, which isn't exactly what we want to do, right? We don't want the inside. Like we want to get the edges. For this case, we want to get the edges. But there's also this case, right, where like the zeros can be anywhere in this. They can literally be anywhere in this ginormous number. There can be multiple, and they don't have to be right next to each other. So slice might not be a good use case for this one. Slice is useful, but maybe it's just not for this problem. But there is one called replace. It returns a new string with some or all matches of a pattern replaced by a replacement. So it starts talking about regular expressions, but we'll just look at their example for now. So it says a pattern. I mean, this one might not be a good one to demo for newer students because regular expressions are awesome, but they take some learning. But not for simple cases. For straight up case, like you can see this example right here. P is this really long string. And it's saying, I want to replace any occurrences of dog with monkey. So it's going to look in here for any matches of dog. And it's going to say lazy, instead of lazy dog, it's going to replace this match or this regular expression, which it's not really, this is the most simplified regular expression you'll probably ever see. It's an exact match. It's saying replace dog with monkey. And so, and this one too. So the quick brown fox jumps over the lazy monkey is our returned result. So this dog was replaced. So this is the search term. So search for dog, replace it with monkey. That's how this method is trying to work. And it does it for multiple things. This is kind of what we want. We kind of want to pass it a 0 and say anytime you run into a 0, replace it with nothing, like get rid of it. Like if you see a 0, just kind of get rid of it, right? Maybe we can try that. I kind of want to, again, we can test this in the console because this is all.
Chris, how come it didn't replace the second dog?
Oh, this is sorry. Python, I think, believe it does. JavaScript doesn't, because it looks like on the very first. Right, good call. I thought I read monkey right here for some reason. I just like eyeballed this whole statement. So it doesn't do it for you, right? So if I wanted to replace multiple occurrences of dog, it looks like I would have to call replace multiple times, which isn't completely what we want. So there was another one I seen right below it called replace all. And this one is using the same example. So this one, replace all instead of regular replace. Replace all the matches. So if we go back and read, it probably mentioned this, right? In this description. With some, so it says a new string with some or all the matches. So how come they got yeah, so here they're using a proper like regex where they're looking for dog. This is like an insensitive case search. Yeah, don't worry about regex. We won't talk about regex right now. That's a little too much to do to explain. So yeah, regular replace looks like it's only doing some, right? It did the first occurrence and it didn't do the second occurrence. So that's the behavior of the replace method, it seems. But there probably is a way. I mean, I'm pretty sure there's a way for you to define regex that would, in fact, replace all of the occurrences. But there is another method. So replace all, you pass it the search term, and it replaces all occurrences, because this one actually like literally says all matches of a pattern it will replace. So this one says where dog was, monkey is, and where dog was, monkey is. So this one actually is performing what we wanted. So that was a good call. I don't know how I even read that last one. I was reading. Yeah, when I was reading this, my eyes are playing tricks on me. All right. Anyways, let's try this in the console real quick, because we want to try it. We don't want words. We want numbers here. So let's do the same thing, right? I want to replace 0 with nothing, and nothing for a string is just an empty string, right? If I want to replace one character of a string, if I want to get rid of it, I can basically say empty string, but you'll see that it has the same behavior that their example had. It got rid of the first occurrence and left the second occurrence. So maybe replace all is really what we want. Or I pretty much lied to you. Let's see. Or I misspelled it. Did I misspell it? I don't think I misspelled it. Replace all is not a method. Okay. Let me just make sure I'm not losing my mind here. Yeah, that's okay. Cool. It's always good. Let me try it in the console here. So make sure this isn't a replace all. I create a variable for a number and use the replace all. Yeah, it's not really appreciating that at all. replace all. Why do you not like that? So number on this line became a string. And this is a string method. So I can call replace all. What am I doing wrong? Are they lying to us? That's fine. I mean, if this doesn't work, we can go about it another way. I thought this would have been a good way to show off more string methods, but it's fine. We can do this another way. We can do it a much more manual way. Oh, what happened? Diverged. I have no idea what that was. Okay. All right. Okay, so this isn't working. I don't know why. That's weird to me that they have a. It's not deprecated, is it? It doesn't say it's deprecated. Oh, you know what? Okay, I'm just gonna skip this for now. For some reason, this one doesn't work. But we could. Does it need to be a string if it's an integer? Command F. What do you mean? This is right here. This is a string, right? So I'm saying number. Let me make sure I'm not losing my mind, because I'm pretty sure. Yeah, it's a string. So number is a string, and for the 0, yeah, that needs to be a string as well. We have to pattern match on a string, so the arguments have to be strings going in. Yep. That was a good question, though. All right, so I don't know why that's not working at all. That is weird to me. I kind of am curious. Sorry. So you run into things like this. I'm inside a node terminal. Yeah, it doesn't see that. Interesting. Let me num string equals 1001 num string replace all. Nope, it does not care for that at all. That is awesome. So there's probably something to that. I'll look it up. I'll look it up after this. I don't want to spend too much time. We'll solve this another way. So we ran into a problem with this. This is fine. We can adapt. We know that if yours worked, yours worked. That is awesome. Am I loose? Do you want to just DM me your line of code that you wrote, maybe, or lines of code? We can solve this another way. I just want to show you that there's I guess, if ideally we would have yeah, that's what I pretty much have. I guess I could set it to a new. I could do, but I just did this in the console, so yep. I really want this to work. Maybe show you both ways, but it's not going to be helpful if this doesn't work. Num string replace all 0. And then you converted it back to a number. That's fine. I want to see. Number 2 string. Yeah, it's just not does not appreciate this at all for some reason. But yeah, I'll move on. We'll do it another way, which might actually be a better way to show you. Since you already know how to use for loops, we can build up our own string, right? We can use a for loop and use a condition that says only attach more characters to the string if this condition is met. So I guess alternatively to doing that, I never did finish this, did I? I want a string type. Sorry, I'm going to backtrack here for a second. I want a string type because I didn't finish my thought process. I want to use parse int, pass it a string to return my eventual value. So this might be like maybe our last step that we do. Once I have it once it's a string, I can iterate over it since dot replace all isn't working. That's a new one for me. So all right, so I can iterate over it. So now I kind of had to change what my initial plan of attack was here. So I want a loop. You guys have y'all have seen loops plenty of times. Here I have like 18 minutes to get through this. So let me try not to take too much time. Oh, I deleted my string, didn't I? Num string equals number to string. I need that. But I'm also going to create another one called my result. Wait, what did I call it down here? Yeah, result string is empty. I'm going to do something with that. Concatenation, right? We learned that you can concatenate more numbers, right? I can keep concatenating. So I can do that while I'm looping. I can combine looping with a condition and do string concatenation based off of a condition, so that I basically can filter out my zeros, is what my plan has now become. So my num string has a length because now my number is a string. I can ask it about its length. I++. So this is the standard loop yet again. My num string, so let's still pretend that this is 1001. So it should have become this now, 1001. So I hope setting all these variables is helping you break down the steps easier. I'm trying to do this on purpose. Normally I wouldn't set excess variables in this case, but I'm going to do it on purpose because on our first iteration, we should have a 1, right? So we can actually ask this character if my character is equal, if it's equal to a 0. Well, this is one side. Is this a good way to state it? Maybe not. If my character is 0, what do I want to do? And my thought is nothing. I don't want to concatenate it to my result string. So maybe I would say not equal. Whenever it's not 0, I want to add it. I want to append it to my result string as we iterate, right? So I want to say result string equals results, my current value of my result string plus, and the plus sign is going to help us concatenate a string to a string. So hopefully the process that would have happened here on our first iteration, again, it would have been an empty string plus 1, which would have given us 1, right? And then the second iteration, the only time it's going to append this number is when it's not 0. Anytime it is 0, this doesn't happen. Basically, the loop just goes to the next thing. If this condition is not true, it doesn't happen. But when it is true, when char is not 0, we do this logic. That makes sense. Now, we can console.log inside this condition, and it will only console.log our values that are not 0, just to ensure what character we are on inside of our condition, right? Like I can ask it, like, hey, run this. Oh, I did that wrong. This is good too. Nobody said anything in chat. That's good. That's my mistake. So if you see what I did, I do it, right? So I totally made an assumption here. Even though I wrote it down, I'm expecting a string data type to be in here, and I'm trying to compare a string to a number, and I'm using the strict equal sign. This isn't going to work. Because I've converted my string to like I've converted this number into a proper string. Like every character is going to be a string value. So I kind of need to actually do this, if that makes that makes more sense. So I have to compare the data types the right way. So now because we shouldn't have seen the zeros. The zeros should only have the only time we should never see a zero inside this condition where the console.log is. I should just see ones like that right there. So I don't know if everybody caught that. So that was my mistake. I was comparing a string to a number type, and that was just logical error. There was no error as far as the code, like JavaScript was concerned. It was like, hey, I'll just do whatever you tell me. Like the number one in the string is not the same. Like I can't compare. It will never be the same, even if it was this. If I had it this way, this will also wait, yeah, these are never true, right? Like this zero is never equal, so this whole statement is true. These are not equal. That's a true statement. But if I did this, it gets nothing. Like they are not equal to each other, right? I just want to make that clear because this is why data types are always important. Making sure you're comparing the right data type to the thing. So if you get some weird problems like that, like that's not supposed to run. All right, so we get a 1 and 1, right? And then I can still test this one more time. I can just make sure that after my loop ends, do we have the right value? And this is just me testing it before I put my return statement in. I'm just doing console.logs the whole way just to ensure that what I see is what I'm wanting. So now there's still one more step we have to do, right? Like I wanted to use parseInt. I'm using a string because I wanted to pass my string to parseInt. So I have my string, it's ready to go. And I can use parseInt, but let me first take this line and test it. And I can see that the console has changed the color of it, but now it's being represented as a number instead of a string, because this way would have been wrong. I would have been returning our expectations here. It didn't say quotes around it. It needs to like numbers always show up like in this color. So I'm just taking notice to all these like little subtleties of the input and output expectations. And then, so now I can go ahead and I can get rid of these lines. I can return my result back from my function call and console.log my result, which should be, and let me reload this. It doesn't like how many times I'm hitting run. Yeah. All right. So when we run it, I still have a couple console.logs in there, but we can see that the last line, result is 11. And that was for this line that ran. So we could also run this to test. I could put this number in its spot now, and hopefully I get 5, 6, 8, 1, and 9 if I put this in here. So I'm going to copy these two values for my own sake. And I'm going to get rid of these console.logs because, well, I think there's just one. Yep. All right, so running it with this, 5, 6, 8, 1, and 9. So that's exactly what we're expecting. But that's how you can manually, when you combine, anytime you combine a for loop with a condition like this, where you're only accounting for like one true side of the condition, I'm ignoring the else, right? I'm ignoring the other side of the condition completely. This becomes, the whole process of what I'm doing here is kind of like filtering. You can think about it that way, where I'm iterating over my string. This could be an array or a string or some kind of collection. And I'm basically filtering out values I don't want. I'm saying I don't want zeros. If there is, anytime it's not a zero, reappend all of these into a brand new string, and then eventually give me a string without the thing I didn't want in it. So this is filtering. There's actually built-in methods for doing filtering, more intermediate and advanced programmer methods that you could use. So this challenge can definitely be solved different ways. I don't know why replace all didn't work. This is probably a JavaScript thing that I'm not familiar with. Why is it in the docs if you can't use it? Yeah, I'm gonna have to look into this because I'm probably just skimming right over some important detail. I'm gonna look at this because we could have solved it this way. Though we could have also just not done this manual way, and I could have used dot replace, because we know that worked, right? Like I could have said, here, let me do it in the console, because maybe that will, if I change everything I have right there, I might confuse everybody. So result string 1001, right? And oh, our shell still remembers what we were at. Wait, that wasn't my problem, right? So if I do new result like this and I do a replace, we already tested this once. I want to replace 0 with nothing. And new result still has the original value. It wasn't actually replaced, but I technically could do new result equals new result dot replace, because the return value that comes out of this is going to now, it's going to take the new value and reassign it, right? So what if I do that? And then I say, all right, new result goes back. Now what if I do it again? Now I get 11. So new result, if I do it twice, for every time that there is a 0 in there, I could do a replace. So I could iterate, and if there is a 0, I could just change this line to say, result string. Oh, my throat's getting dry. Result string 0. I could do that, right? Like I could reassign and make it replace the 0. But I mean, neither of these are really. These are both fine ways to do it. Probably, we're not changing much code. We're not getting a huge benefit of doing that. So, I mean, I would say this is probably fine. We don't have to write optimized code here for intro level. It's not something you have to worry about even as an entry level developer usually. But this is a fine solution, right? Like we're just filtering out zeros that we don't want. Were you able to follow all this? Was that Cindy that was asking that?
Yeah, I wanted to see that. I think Deborah did too. Yeah.
Yeah. Yeah. So.
Yes.
Sweet. Yeah. If y'all were able to follow all that, it's I'll put this in Slack too, just so you can. I think I wrote maybe a little bit better comments for this one, and I'll go in and touch up the other ones. This one, I'll go in and touch up this one with some better comments, because this one got a little unorganized while I was doing it, and I'll put this one in Slack, and I'll put this one in Slack, because we have like 4 minutes left. But if anybody else has any like last minute questions, just let me know. I don't know how you got replace all the work. For some reason, mine did not work. I don't know if anybody else was able to try it, but that is super. Let me try const and my very new, make sure I don't use a variable I've already used. Very new string replace all. Yeah, that's odd to me. Why? It doesn't, doing this is repetitive, but it doesn't see replace all as a method of a string, which is interesting. Anyways, I'm gonna look into that because that's, I don't know, maybe that's just this can't be a replit thing because it was happening to my node on my own system. And it's fairly recent. All right, anyways, yeah, if anybody has any questions, just let me know. We got about 3 minutes left. And again, the recordings of session 2 and 3 should be pending, or they might be up by now, hopefully. And then this one, my computer has to finish processing it, and once it's done, I can send it to the instructor, and then hopefully I can get them to upload it by tomorrow. So if anybody wants to rewatch any of what I did today, you can rewatch it. But yeah.